Okay, this series of lectures covers material in chapter 10 and 11. We're combining these two chapters because they both talk about food chemistry. So we'll look at how we cook food and how that is related to chemistry, and also what is in food, different nutrients and different components such as proteins and carbohydrates. So we're going to first start with looking at topics associated with recipes and measurements and some general chemistry of cooking. So one of the things that we've talked about throughout the semester is unit conversions. And this comes into play when we're looking at recipes. We've talked often about how the American system or the empirical system of measurement is different than the metric. We've converted between inches and centimeters, kilometers and miles. This comes into play when we're looking at recipes also. If you are to get a recipe that has a European origin, chances are the ingredients are going to be displayed in mass. Great, you use this many grams of sugar, this many grams of flour. In the US, we typically use measurements such as cups. This also comes into play when you're looking at temperatures in which something is cooked and also dimensions of a pan that you're using. So if you, these are some examples of some of the unit conversions between the American and the metric system. Our oven temperatures, we've done these conversions between Celsius and Fahrenheit. Other things such as cups of flour and how that is related to mass, and we'll look at that in a little bit more depth in a second. Weights, ounces to grams, dimensions. So if you were to have a 13 by 9 pan, that's the same as saying 23 centimeters by about 32 centimeters. So we have to be able to do these conversions if we want to convert recipes. One of the major conversions is related to density. So in the US, we tend to use cups. The mass of 1 cup of flour is not the same as the mass of 1 cup of sugar. So for example, if you were to be measuring out 1 cup of flour, that mass is 130 grams. 1 cup of sugar is more dense, so that's 200 grams. So we need these unit conversions in order to convert recipes. Here's an example of those conversions. These are the same as the conversions that we've done throughout the semester. So if we look at flour, that unit conversion is 1 cup of flour is equal to 200 grams. So if we have a recipe that says we want to use 1.5 cups of flour, so 1.5 cups of flour, if we multiply that by our conversion unit, 120 grams is equal to 1 cup. Those cups cancel out, and that leaves us with 180 grams of flour. So if you were looking at a recipe that called for 1.5 cups of flour, you don't have a measuring cup, but you have a balance, you could weigh out 180 grams of that flour. Next, I just want to look at how chemistry comes into play when we're talking about cooking. Throughout this course, we've talked about chemical reactions, and we've also talked about the physical changes in molecules and compounds. Cooking results in both chemical and physical change happening. An example of this would be cooking an egg in a frying pan with some butter. The first thing you might do is throw some butter, which is in the solid phase, into the frying pan and allow it to melt. This is a physical change. You're going from a solid to a liquid, but you're not changing the chemistry of that butter. You're not breaking any bonds. When you actually cook that egg, chemical reactions are happening. So what happens is you put that raw egg into a pan. Bonds within that egg, this is showing some reactions that might be happening with the egg whites. So bonds are breaking, resulting in changes in the molecules that exist in that egg. And as a result, that egg is cooked. So the heat that you're adding to that egg is breaking bonds, resulting in that egg cooking. So chemistry comes into play in how we cook. It also comes into play in recipes and explains why we add certain ingredients. We talked about surfactants when we were talking about polar and nonpolar molecules. So remember, surfactants are chemicals that can be added that allows a nonpolar and a polar molecules to mix. We have this in cooking. Egg yolks, mustard, sodium phosphates are all emulsifiers. Emulsifiers is just the same thing as a surfactant. Emulsifiers is used when we're talking about cooking. You see sodium phosphate added to a lot of foods. This is because it is an emulsifier. This is also why you see mustard added to a lot of foods. Some examples of foods that require emulsifiers: peanut butter. If you take natural peanut butter, just peanuts ground up, you get a separation of the oil from the rest of the materials in the peanuts. You get an oil slick on top. The reason we don't get this in a lot of our processed peanut butters is because an emulsifier has been added. Mayonnaise is another example. If you did not have an emulsifier in mayonnaise, you would get a separation of the oily and non-oily components. We find emulsifiers in almost all of our foods. Salad dressings are another great example. A typical salad dressing has a vinegar component and an oil component. Those would separate because polar and non-polar. We add an emulsifier and those maintain the salad dressing without it splitting. Oftentimes mustard is used in salad dressings as an emulsifier. So chemistry is important in cooking. We're going to look at how chemistry comes into play with different cooking techniques, and then we'll take a look at different components of food.